Alright class, so this video, it's going to be extra long because we have to cover a lot of stuff. So that means you're probably going to have to watch it, pause it, and rewatch a few things to get everything out of it. So again, I apologize in advance for this video being so long. But what we're going to start off talking about is x-intercepts and y-intercepts. But first, what's an intercept? When I hear the word intercept, I think of football, interceptions. So what happens in an interception? An interception is when the opposing team catches the ball from the current team with the possession of the ball. In other words, the player crosses the line or the path of the football. So the player crosses the line or the path of the football. When we talk about intercepts with graphs, we're talking about the graph crossing the line or path of our x and y axis. So the graph crossing the line of the x or y axis. So the x-intercept, we're talking about when the graph crosses the x line. So again, the x line, the one that runs horizontally. Look at this example right here. How many times does the graph cross the x-axis? It crosses it right here once and right here twice. So there's two intercepts. Two intercepts, okay? Let's do another example. Here, the graph is just touching the x-axis. We say this is still intercepting it. So the graph is crossing the x-axis. So here's another intercept, but there's only one x-intercept this time. One intercept. Okay? Now lastly, I'm going to erase this graph. Excuse me, no, I'm just going to write it right here. Another example. Looking at this graph, do you see it touching the x-axis at all? No, it's not. It's floating up in this space right here. It's not even touching the x-axis once. So this has 0 x-intercepts. So 0 intercepts. So notice these are our only 3 types of intercepts. You can have 2 intercepts, like the top image, 1 intercept like the bottom, or 0 intercepts like this image on the right. Okay? Now I'm going to erase these, especially this one right here, because I want to work now with y-intercepts. So a y-intercept, we were first talking about when the graph crossed the line of the x. Now we'll be talking about when the graph crosses the line of the y. So let's draw a graph. So we have our graph, and notice it crosses the y-axis right there. So the y-axis, it was crossed once. So there would be one y-intercept. So one intercept. Now in this graph you can see the x-intercepts, but we're not talking about those right now. We're talking about the y-intercepts with this graph. Okay? So this is the only combination you can have with quadratics. There's always going to be a y-intercept, but you may not see it right away. Example quickly, you may see something like this. It looks like it's floating up in this top right part of the graph, which we're going to call a quadrant in a little bit. But eventually, if you zoom out, and out further, you will see it eventually cross the y-axis somewhere way up here. Way up in space where you can't see. So eventually it will cross the y-axis. So there's always a y-intercept, but there's not always an x-intercept. The last part I want to point out when dealing with intercepts is what x and y values are there for them. So let's look at the x-intercepts. First example. For the x, we move to the right a little bit, to the left a little bit, then we move to the right a little bit. But we didn't move up or down at all. So in other words, the y didn't change. So for x-intercepts, your y is always 0. So y is 0. Okay? So no matter what, when you're talking about x-intercepts, y is going to be 0. looking at y-intercepts. What's the x value when we cross the y-axis? Well, we're not moving over at all, and we're not moving left at all. So the x is 0 in this instance. So with y-intercepts, the x is 0. And with the x-intercepts, the y is 0. So they're opposites. Okay? That's all I want to talk about with intercepts. Now I want to move into quadrants. So I'm going to quickly erase this. And I want to ask everyone, what do you hear when you hear the word quadrant? You might hear the word quad. You may think of your quads, which is a leg muscle, and there's 4 muscles acting in that quad section. You may, ooh, that was a shock. You may think of a quadrilateral, which is a 4-sided shape. So when we hear this quad part, we're thinking 4, okay? And what quadrant means is different sections of the graph. In other words, 4 parts to the graph. So what I mean by 4 parts is we have our graph grid and we divide it or name 4 parts. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay? So it's just a quick way to name some things. So if you were asked, graph a parabola in quadrant 1, you would simply draw it like this. The parabola is in quadrant 1, one of the 4. Another example. Say you were asked to graph a graph in quadrant 4. That would mean something like that. The graph was in quadrant 4. Let's try something else, a little more specific. Graph a parabola in quadrant 2 with 2 x-intercepts. So we're drawing a parabola in this area, this quadrant, and we need 2 x-intercepts. So x-intercepts, we're crossing this axis, the x-axis. So we're in the quadrant 2, we have an x-intercept here and an x-intercept there. We fulfilled what we were asked. Okay? How about this? Graph a parabola in quadrant 1 with 1 x-intercept. Okay, let me erase this one. And here we go. We're in the first quadrant, and there's only 1 x-intercept. Okay, so quadrants, breaking the graph into 4 different parts. 1 is always here, 2 is always here, 3, and 4. In a counterclockwise motion. Counterclockwise. Opposite of the clock. Okay? Now, we're going to move into the equation parts of the work. So I'm going to erase this.